Hey everyone, welcome to this explainer. So I was recently going through some incredible source material, and it dug into something that, honestly, might just sound like regular official protocol at first. But we're going to see how it's actually the absolute backbone of quality and safety in electrical engineering. We're talking about the ITP. If you're a QA engineer, a project manager, or just someone who looks at massive, complex projects and wonders, how on earth does this all come together without a disaster? Well, you're in the right place. Let's dive right in and unpack how quality is literally engineered into a project from day one. All right, let's start off with a massive question. When you're looking at a wildly complex electrical project, maybe it's a huge power plant, a commercial high-rise, or some mega industrial facility, what actually guarantees its safety? Like, way before you even think about flipping that first switch, what's the invisible force preventing a total disaster? From the outside, you see this shiny, finished product, and it feels like it all just magically came together. But in reality, there's a fiercely strict, perfectly orchestrated framework holding the whole shebang together. Okay, let's dive into this, because the stakes here are unbelievably high. Just think about what goes into these projects. You've got thousands of meters of cable routing, incredibly precise terminations, grounding systems buried deep underground, massive panel installations, and really intense equipment testing. If even one of these installations fails, we're not just talking about a minor headache. It can be absolutely devastating. We're talking severe safety hazards, massive system failures, and a total lack of long-term reliability. So the big question is, how do we make sure every single one of these high-stakes activities is done flawlessly? And that is exactly where the hero of our source material comes in, the Inspection and Test Plan, or ITP. Now, a lot of people make the mistake of thinking the ITP is just some boring, bureaucratic paperwork or generic checklist. No way. The source material makes it crystal clear that the ITP plays a totally central, vital role in the world of electrical quality control. It's literally the core mechanism that guarantees every single electrical task meets the exact project specs, strict safety requirements, and industry standards. It's basically the anchor that ties everyone on site together. Let's actually look at the formal definition from the material for a second. It defines an effective ITP as a structured guide for quality, defining how inspections, tests, and verifications are carried out throughout the project lifecycle. Now, I really want you to focus on that phrase, structured guide. This is your ultimate blueprint. It doesn't just tell you what the work should be, it maps out exactly how that work is going to be verified, step by step, from the very start of the project all the way to final handover. So how does the ITP actually maintain this level of control? Well, think of it kind of like traffic lights for your project. The ITP sets up these crystal clear milestones. They're called hold, witness, and surveillance points. A hold point is your absolute red light. Work literally cannot proceed until an inspector comes in, signs off, and gives the green light. Then you've got witness points. Think of these as yellow lights. You invite the inspector to be there, but if they aren't, the work can still keep moving. And finally, surveillance points are like a green light but with a speed camera. Work continues, but there's constant routine monitoring to make sure rules are being followed. These points are absolute lifesavers because they stop bad, unverified work dead in its tracks before it gets covered up by the next phase. Setting those points is great, but the ITP goes even further. It dictates the exact sequence, or order of operations for all electrical inspections. For instance, you can't just go and test a panel before you've verified the cable routing. You definitely can't verify terminations if you aren't absolutely sure the grounding system is solid. The ITP forces this logical progression. It makes sure no critical electrical activity is ever skipped, overlooked, or done out of order. It basically creates this unbreakable chain of quality. Now, let's talk about something huge: alignment. Just picture the absolute chaos on a mega project if this document didn't exist. You'd have the contractor doing whatever they think is best, the consultant expecting a totally different standard, and the client demanding something completely out of left field. That kind of misalignment is a literal nightmare. But the ITP, it prevents all of that. The source points out that one of its main jobs is getting the contractor, consultant, and client all on the exact same page regarding quality. When everyone shares the same ITP, you get this amazing harmony across the project. Everyone agrees on exactly what done and done right actually means. But hey, this isn't just about doing the right thing in the moment, it's about proving you did it later on. Through structured checklists and documentation, the ITP massively boosts your traceability. And for those of you out there in the field, listen up, because this ties directly to your professional reputation. If a system fails 5 years down the line, these structured checklists are your hard proof that you executed your work perfectly according to the standards of the time. This documentation doesn't just protect the project's integrity, it literally protects you and your entire team from taking the blame. This is where the ITP really proves its worth, its true return on investment. By catching issues early in the execution phase, it minimizes incredibly expensive rework. Let's imagine a real-world scenario based on the source material. Say you spent days installing this massive, complex control panel, doing hundreds of tedious terminations. Then, out of nowhere, you realize the foundational grounding system underneath, which is probably covered in solid concrete by now, was never actually verified. And guess what? It has a fault. Just imagine the absolute nightmare of tearing out that entire panel installation and ripping up the floor just to start over. It would destroy your budget and timeline. An ITP forces you to catch that grounding issue on day one, saving you an immense amount of time, money, and sanity. If we zoom out and look at the whole life cycle, the source material maps this out beautifully. To guarantee safety, performance, and long-term reliability, electrical installations need continuous verification. A well-crafted ITP ensures these processes are followed through three main steps: planning, inspection, and documentation. The ITP is essentially the golden thread connecting your initial plans to the physical site inspections, all the way to the final documented proof. I actually want to share a direct quote from the source material right now because it perfectly captures everything we've been talking about. It says, "Quality in electrical projects isn't an afterthought. It is embedded in every step of planning, inspection, and documentation, and an ITP is one of the essential tools to achieve this." I absolutely love that perspective. Quality isn't just a coat of paint you slap on at the end. It's a deliberate, engineered process. It's literally woven into the project's DNA, and the ITP is the exact tool that puts it there. Which brings us to a really provocative question to wrap things up. If an inspection isn't documented in your ITP, can you really prove it ever happened? In this high-stakes world of quality control, unrecorded work is basically undone work. A rock-solid ITP is your ultimate guarantee that critical processes weren't just followed, but irrefutably proven. And that is the absolute essence of quality. Thanks so much for joining me on this deep dive into the backbone of electrical quality. Keep your work structured, and I'll catch you next time.